Recording has started. I hope you can see my screen also now.
Yes.
Okay. This is the objectives and the participating projects, and also the deliverables and the timeline. I've talked about this in every meeting so far, and you can see it. So I don't talk more about that. The agenda for today, the meeting number 4, is presentation of the ISO 10303, 239 and 242 standards, and Torbjörn Holm is doing that. And the recording so far is available on the PCA YouTube, and this will also be put on the PCA YouTube after this meeting. And I will put it up also on OwnCloud for the PVN project. Also, the presentations will be put on OwnCloud. But also we will put it on the PCA website also, but we haven't done that yet. And with that, I think I give the floor to you, Torbjörn. Is that okay?
That's okay. Can you hear me?
Yes, loud and clear. So just take the screen.
So I'm Torbjörn Holm. I'm working with Nils in the Arrowhead work package 3 about major standardized languages, engineering languages or standards. And I'm also working with implementation architecture in work package 9, which is about process industry, where we work together with Stora Enso and Roslagsvatten and many different companies. Today I will talk about STEP, and it's a lot of things you could say about STEP, but this will be an overview and why it's one of the major standardized engineering languages. The scope of STEP, ISO 10303, it's including a lot of product types. And first of all, I have to say that if you are coming from process industry, what we talk about here is the product that in the sense of a car or a pump or something like that, that's being used by another process to produce other products like oil or other services and so on. So it's not the stream that goes through a process industry plant or something like that. Product types such as electronic, electromechanical, mechanical, sheet metal, fiber, composites, adding up to automotive, defense material, or aerospace is the most important things that in scope for ISO 10303 STEP. And the idea is to cover all stages of a product life cycle, including requirement management. There's work been done together with Incose that's on requirement management, information management. It covers design, analysis, planning for manufacturing, planning for maintenance, manufacturing, usage, maintenance, and disposal. So from a product point of view, this is some kind of life cycle. Nowadays, we don't see it as a linear thing. It's a circular thing, since it's not always disposal. Most often, we like to have a reuse and get back to some stage earlier. It could be to reuse, but it could also be remanufacturing and so on. And it could also be that you use it as an input material for a new production of sheet metal or something like that. The focus is exchange of product data among different computer systems and environments, ensuring that product information can be shared and understood consistently across various platforms. Notes very different to other standards, but this has been the scope from day one of this standard. One very interesting thing is that STEP used the same kind of reference data as 5926, now and then a little bit differently, and I will show that later. But there's a consistency in looking at reference data, and that's of large benefit, especially for STEP, I think, I'd like to say. Another thing that some of the people especially in Arrowhead, are interested in ASD S1000 series. And the models there are based on what has a common ground in the STEP standard, and one of the standards that we will look at a little bit later. Little bit of history. ISO 10303 started its work in 1984. It was in the group called, you could see in the bottom there, ISO TC 184 Subcommittee 4. And the first version was released after 10 and a half years work, 1994, 1995. And you could say that took a very long time. But it was an ambitious target to do a model-driven thing. And at that time, there were no modeling languages like UML or SysML or OWL or anything like that. So you could see the initial release has to include part 11, it says Express. That was an information modeling language that had both a lexical nomenclature and a graphical way of modeling. This was long before other information modeling languages was formed. Since we wanted to have everything being driven by the information model, and we created a mapping from the model in Express to a file format called Part 21. And there are a lot of Part 21 file exchange going on all the time, since many CAD systems are sharing CAD models between different tools. in a Part 21 file format. You could also see that Part 42 was a geometry model. Part 42 is an CAD system neutral geometry engine or geometry ontology. We didn't call it ontologous then, but it's a model with the semantics to describe shapes. And that was one of the key success factors here. You could see later it says AP201 and AP203. The things that the user of this standard is accessing is something called the application protocols. And the application protocol is used in the business transaction or in a business process to exchange or share data. AP201 is an exchange file form or a model for drawings or schemas and things like that, two-dimensional things, while AP203 was the CAD exchange standard, and it was started to use immediately. Projects like Eurofighter and others large aerospace project was starting to use it directly, perhaps too early, because it created a lot of error bug reports. But it's been used since then, since mid-90s, this standard. I like to also position this as there's a lot of knowledge in these standards. The standards that's been used now for 20, 30 years. The technology is not really up to date. Today, the technology would like to be expressed using defined by World Wide Web Consortia and others, and not by one subcommittee in ISO. And that's why we are so interested in these major engineering languages to see if we could bring this knowledge in these standards to a new technical platform. And that's what Nils and I am working with. I will talk about in more detail two application protocols, one called AP242, Managed Model-Based 3D Engineering. This is the third AP in the scope of CAD data exchange. 2 or 3 was really as CAD data models. AP214 added some things that had to do with 3D models. And this is about managed model-based 3D engineering, and it includes a lot of different things. This is a standard that is heavily used in automotive, aerospace, and other mechanical manufacturing sectors. It supports many different kinds of geometry models. It has a product data management part, and one important thing is that many organizations and government require that you archive information about a complex product in a neutral format, and that's why they used AP242 also, to be able to archive and retrieve engineering data in a neutral format. Another standard called AP239, Product Lifecycle Support, PLCS. That is a standard that is developed to support the exchange and management of product lifecycle data. It deals with the entire life cycle, from design and manufacturing to maintenance and disposal. But it is not including any shape definitions that taken from AP242, but it includes the definition of a maintenance system alongside the definition of a product. If you think about products like warship or an fighter, an airplane, and things like that, the maintenance system is as important as the product itself. And that's why this is supporting the development of a maintenance system, maintenance product alongside with the product itself. It is useful for managing complex products and their support solution, as said, including configuration management, variant management, and so on, maintenance planning, and recording of usage and activity history. Some of you are also involved in with the S1000 series, and you say we do that also. Yes, there is the ASD community has developed this further, but the basis is this, and that's why I think it's rather interesting to look into these standards. If you position these application protocols or these standards, you could see that we deal with things like systems engineering, it says. It's AP233. Today, that standard is totally included in this light blue thing called AP239. So you could really say AP239 also for systems engineering. In the dark blue, you see that there is a design for the product that's been asked for, and there is also standard for multidisciplinary analysis of products. This is doing simulation and analysis like finite element things and other kind of simulations. You see in the orange arrow, there's that says AP242. Yes, it provides data to something called AP238, which is about system neutral manufacturing information. And that's about how to cut metal, how to produce sheet metal things and so on, and that's in AP238. When the product is developed and produced, it goes over to product support, and you could see in the light blue that alongside the design of the product, you have designed the product support solution, and that's instantiated to support the products coming out, and that's the product support process. And the usage of the product is also in this AP239 that we will look into further. And that's a part of providing information for maintenance activities, trigger spare part changes and so on in the product support solution. If there is engineering change requests, you need to do modify design and of realized products, and that's also done, of course, with 242 and this 209 to calculate that to check that validate the product for the usage that's planned, and how to modify that in a fleet of aeroplanes or cars or that's used by AP239. So this is a comprehensive and working ecosystem for the life cycle of complex products, especially when they are long living. If you have something that is used for 2 years, perhaps this is too much. But if you have something that will fly for 40, 50 years or something like that, this is needed. Perhaps they do it without some of these standards, but the scope of such an information management environment is this. Just to position this application protocols to each other, you could see that there is the information management here, and then we have the life cycle up here, and you could see that AP242 is here, and it has an overlap with AP238 for CNC and integrated machining and so on. AP239 and together with AP233 is the PLM data management through the life cycle. And but there are other things needed, and one of the things that I talked about is this ASD, ILS things, and other S1000 series things, and they have an overlap with 239, but have extended that. The aim is to have a good coverage for this kind of product, long living, complex product with safety and economic critical products, to have an information management that is integrated and interoperable. And that's been the goal all the time for these standards. Some of the standards, some of the APs, is about 40 of them, are not really used at all, and some is rarely used. That's why I concentrating on the one you see here, AP239, AP242, AP238, AP235 are things that used every day in industry. This is a picture of AP242. It says that it's managed model-based 3D engineering, and you see the illustration of it through the life cycle. If you like to have more information, make a note of that website, www.ap242.org. This is an ISO standard, and ISO has an idea about making money out of selling standards. So it's not like downloading a standard and start to use it. They are governing it in a very good way, and it's stable and it has very quality good processes, but you need to pay for the standard. But if you go to this World Web site, you could get very good information about the standard. But if you're going to implement it, you need to buy it. But if you are a techie guy or girl, you can download the schemas. If it's Express or if it's SysML or what it is, you could download it, XMI I mean. You could download this and start to use them. But if you need to have a more readable standard, then you need to probably buy it. This is the content of AP242. We have PDM, traditional PDM, you know, part structure, properties, activities, document management, physical parts, activity, work management, and so on here. It's not really PDM first release, it's a little bit more closer to PLM, but this is a part of this and main part of the standard. There is requirements, validation, and verification to plan for this and keep track of them. How to deal with mating definitions, that things are connected to each other, rules, process planning, analyze management, kinematics, interfaces, electrical wiring harness. You know, this Airbus 380, they had a problem, so they couldn't start to fly because they had a electrical wiring harness problem, and they had not used this at that time. and they mixed two different tools, and that was not a good idea. Then you see there's a lot of other things here. They deal with shape data quality for BREP geometry, and there's a PMI, that's the way you define tolerances and so on. So this is a really comprehensive standard. It also includes parametrics and explicit 3D shape, and things like point clouding, 3D scans, and additive manufacturing, and so on. This is, as I said, in use every day, and a lot of the business processes going on by different car manufacturers, for example, they are utilizing this to share platforms and so on, to share cost of developing new products. But this is a real important part of that. This is another standard then called product lifecycle support. And this is just an overview model, or a high level or concept model, perhaps I should say. And I have marked some of these things. We have a product, and there are, I will talk a little bit more about that. There are product individuals, we have activities, and then we have activity methods, defining how you should carry out an activity. You have locations, and you have states, and you have resources. Resources can be persons and organization, it could be skills, it could be spare parts, and it could be tools, and so on here. And so there is a lot of relations and a lot of different concepts in this. But coming from Dirk's presentation, I wanted to point out what is the high level things. One very important thing is product, and the product, as I said, is a little bit different here. Product here is, from the beginning, it was something that was the result of a process. That's a product, and something moves from one process to another process as one unit, and that's typically parts and systems and so on here. But then they started to model also everyone that needed to have this typical step thing, that you have a product, you have a version of the product, and you have a definition of the product. Then they started to say that everything was a product. It doesn't make it easier to understand, but the requirement is a product, and the breakdown is a product, and a slot is a product, and a document is a product. Some of them is obviously a product, and some is a little bit hard to understand. Today, when we are looking into doing IDO version of this standard, this will probably go away, that we will not use, this is very much like the IDO object if you are into that. Product individual is important. That's something clickable, some a pump that you can carry around and put on the stock and move into a specific function location and remove it to there, send it to refurbishment and so on. And that's very important here when we deal with the definition of the maintenance system, because the maintenance system includes that you refurbish things at the field, or bring it back to the vendor and so on, and you like to get it back and use it again. As I said, activities, temporal things, and how to, the recipe on how to do things. Locations is, of course, very important also, keep track of, and the state of these things, especially the product individual, is of course of importance when you're going to trigger an activity to say, make a work order to adjust some things. There is a lot of other things here, and these things are possible to use in context of all these different things up here. So you have effectivity. Is this information set valid for this usage or in this time, or things like that? And you have date and time, you have conditions, you have risk, really important, and so on. So this is a lot of knowledge in this. If you're going to do a risk management tool, I've done that, and look into these models, because there's a lot of knowledge behind this, and you could use the information structures to build a database for such a tool. I need to check how much time I have used. I can talk about this for 5 years or 2 years or half an hour. This is, if you like to look into this more, you could go to this site, www.plcs.org, plcslib, plcslib, and it's open. And here you see the same high-level model. And if I click on this, I think I will get there. Yes, and this I can go to this concept model, and now I'm back here. This concept model, and that's this one, includes these blocks of information. And right now I'm trying to see if these things are also their own ontologies, and I think so, but we are looking into that now. So if I go to, like I say, I'm interested in managing the breakdowns of a pump system, the reference designations, and then I can see here I have a clause, a breakdown. A breakdown provides a means to subdivide something of interest into a set of related elements to which additional information can be attached. And so there is definition for all these different things, these areas. If you look at product down here, and then you see a product is a parent concept for part, system, and all the different types of product in PLCs. Rather strange definition, I think, but that's another thing. So there are definitions all over the place here. But if you like to know a little bit more detailed information here, there is this. And then there is SysML diagrams for everything here. I said before that everything was modeled in Express from the beginning. Nowadays, most of the standards, both 239 and 242, do have Express in the bottom somewhere. But the modeler who is doing changes on this and maintaining this is doing this on SysML level. And here you see there's a lot of diagrams, SysML diagrams. And these are all the blocks, all the classes it deals with. And it adds up to many. But we can look at one of them, like product again. So this is the way it looks like on this level. We have a product, and the way this is typical step modeling. It says that there is something called a product relationship, and it points at the product. That's the relating product, and it has also a related product. That means that a relation between two products is utilizing this objectified relation called product relationship. And the same goes for a product version. It's a version of the product, and it has versions. The product has versions. A product version cannot exist without a product, but a product can exist without a version. And so on. There's a product version relationship and supplied part relationships and so on. And You could see here that we have a product view definition. That could be, I like to see this product version from an electrical point of view, or from an maintenance point of view, and so on. So the summary of all these views for this product version is pointing to this product version. You can also see that we have properties here. We have a classified as, that goes to the classification, and then we are connecting into 1596 or something else that is a classification. We have a description, and we have an identifier, and we have something called same as here. And that means that you could say that this is this thing, this product view definition instance is the same as another product view definition. If you look at, if we point at one of these, as we could take this product view definition instead, you could see here that there is a comprehensive definition, very similar to what we have when we deal with OWL and IDO and so on. It's on these diagrams, product view definition. It has these supertypes, many of them. It has subtypes that is used by, and it has an OWL definition here. And it's product view definition is characterization of a product version relevant to one or more application domains and for one or more life cycle stages. So you could say this is for requirement management for electromechanical, and that's a product view definition. And then we have the properties and the constraints. So that's what we are trying now to convert into an IDO-based thing, and I think we can get there, but we are not there yet. And we need to do it in some way that it's possible to do with support of a machine. Otherwise, it will take too long and be too hard to do, and it will be error prone if you do it by hand. I like to end up with something that's really interesting, I think. There is something called step 4000 or part 4000, and that's the core model. And it's really the overlap between these two standards that I talk about. Step AP242, owned, really heavily used in automotive, aerospace, and defense, and product lifecycle support. So the scope of this core model covers this kind of technical capabilities, and then it starts to get very close to things that we have in IDO and so on. Some is a little bit more detailed. There's activities, analysis, breakdown, collection, common resources, document management, interfaces, and so on here. And it doesn't include geometry. It's excluded, since then if you're interested in using it for to include geometry for the definition of individual parts or products or product definition or specifications, then you could use one other step standard. This is a picture of that standard. This is the breakdown thing. And you see here that we have the same kind of structure. We have like a breakdown element version, and breakdown element view. That's element version, element view. And here we have the same kind of structure all the time. It's repeated, but it also have here that a breakdown of itself, like if you are an 81346 person, then you know that there is a location breakdown, for example. Then there will be one instance of this and it will be classified as a location breakdown, and it can have a version, and it has members in it that are breakdown element views. So this has been used to implement 81346 breakdowns for function breakdowns, system breakdowns. Even if they call them function breakdowns, we call them system breakdowns, and we have product breakdowns and location breakdowns and so on. And we can play with this using this structure easily and in parallel, and that's very, very powerful. Just to show you one thing more here. This is the typical, this is the ISO standard, and this is a typical view of an ISO standard in this area. It has a forward, its introduction, scope, normative references, terms and definitions, and so on, just to be able to read this. And we could look at the core model requirements, and we have core technical capabilities, and we could look one of these. We can look at, let's say, breakdown again. Here we see this, and here I can also click on this, and then I get to breakdown element, and this is very similar to what you saw before. This is close to be processable by a computer. This part is probably very well easy to do, but we are also utilizing, there is an XMI version of this, a way to exchange this standard in a neutral format, and there is an old version of this standard, but it's not complete. Right now we are trying to use the XMI version to complete this into an all 2DL standard. We can look at down here. This is core model reference data. So if you look at the breakdown element here, you could see that there is a subclass of this breakdown element, and this is the breakdown element can be a catalog item, a functional element, a physical element, a system element, a zone element. The way they deal with this is by creating reference data, specifying that this breakdown element is a functional element, a physical element. So you externalize the specialization using a class mechanism according to 15926, and that's one of the ideas here, that you try to move out of the standard itself as much as possible. So the standard doesn't grow over all the limit. So this is a fairly new standard. Its latest came out. This is not the latest one, but there is a new one coming out last year. So this is the state of the art for STEP standards, and right now we are trying to do that. We are going to, in one of the use cases in Arrowhead, we will go from DEXP in some format to map that to relevant parts of this standard, to be able to import it to a tool that is going to deal with the digital twin of a process plant system. And it looks rather promising, but we need to have more help with getting this automated translation done from XMI to OWL, and then how to map two ontologies to each other using alignment technology or something like that. This was what I planned to talk about. Are there any questions, or was it totally not understandable?
No, hi. Hi, Torbjörn. This is Alex Garcia from Siemens. I think we were
Hello.
in touch last
Yeah,
year.
I know who you are.
Yeah, no, man. I mean, nice work. Actually, you know that this is um, part of the problems that we have is that we need to create a network of standards. So we cannot have the standards just as PDF. And we need to understand, I mean, we need to have a way so that the machine can understand how the standards are related to each other.
Yeah.
So very nice work. Thank you for presenting.
Yeah, you should talk to Nils because if you are interested, I think it's a possibility to could help each other. I know what you've been doing, and I know that you have input that would be of interest for work package 3 in Arrowhead.
Yeah, I mean, right now, sorry, it's just that I started to take this call when I was back at home, and now I'm just going for lunch. So yeah, part of the work, I mean, since we talk, a part of the progress that where we have had more progress, it is precisely in how to represent the relations across different standards.
Yeah.
So yeah, and there I think we can. I mean there I think we can help, and also in understanding what are the ontological patterns that you should consider when representing these standards, these kind of standards, so that you have sort of an homogeneous representation for the standards.
Yep.
That's where we have had most progress.
You know, I'm also working outside the Arrowhead, so I work with Siemens Energy also.
Yeah,
But
I know.
I think you would be very interesting for Work Package 3 in Arrowhead to have a meeting with you.
Let me
I know
send you
that
an email. Let's retouch, and let me send as soon as I get back home. I will send you an email, and then let's see where we can talk in November.
Yeah, great.
Okay, thanks.
Thanks.
More questions for Torbjörn. It's been unusually quiet today compared with the 3 first meetings we had. I don't see any questions in the chat either. Cleaver, Johan?
Yes, hello, hi. Thank you for a great presentation. Would you happen to have some materials that you could show us to give us an impression of where you are currently at in the work on providing an OWL version of this standard?
I don't know if I dare. I can tell you what I'm doing, what we are doing now. And recently I got new resources in with people that are really deeper into STEP, called Judy Crawford, and I know that some of you know her. And I got approval today but right now we have, or I have, creating on sub-ontology of IDO for these breakdown things that I've been repeatedly showing, including what I believe covering the same semantics as the UML version. But I need to have a review from some IDO people, and I know I talked to Derek, but perhaps you should look at it also, because I'm into new ground. And I'm not sure I'm doing it all correct all the time, or I'm rather sure that I don't do it all correct all the time. So I'm fairly sure we can do it, and I'm fairly sure that IDO will contribute to make this standard more interoperable with other STEP standards, but also other standards coming from TC 184 SC4, and also other standards, like we talk about this CFOS thing, so we talk about the XP, but we also talk about other kinds of standards dealing with these kind of things. My that I'm also sure about, that we can also make an IDO version of some parts of S5000F, because that's very much related to what you see on the screen here. So it takes time though, because you get immediate response when you do something wrong, when you do it with reasoning. So it takes some time to figure out what's wrong now. So.
Yeah, I know the feeling. Regarding breakdowns, we have had some significant progress within the IDO community this fall.
So then we need to talk about that, because what I've done is totally in line with step breakdowns. And there are different ways to deal with breakdowns. But what we have been doing all the time, that we don't, PLCS is not a 4D model, so we really keep track on what is on reference designation and what's on equipment. And how they play together is using relations. And I think that since you are coming from another way of thinking, and now have the same way of thinking, it would be really interesting to look in how you do it in IDO now.
That sounds very inspiring. Obviously, IDO is primarily a 3D ontology. You can have 4D concepts in there with activities, but most use cases focus on 3D. And, so
that's good. And what we have in PLCS is, of course, a lot of activity, planned activities, carried out activities, and activity methods, and directed activities. There is a lot of different kind of activities in scope of maintaining a complex product. So we could do a comparison coming from that end, what has been documented before, to needed to cover this kind of scope, that you have a complex product and with a lot of maintenance definitions. And I think that goes for all the things that is involved in IDO right now.
Yes, excellent. Thank you.
More questions or comments are very welcome. Mikkel?
Yeah, hello. You mentioned SysML and XMI formats of many of these artifacts. Is this, I guess this is SysML 1.2 or something?
Yes, you're right.
And there's working on the new one. How do you deal with that? The new SysML coming up?
Yeah, I trust Nils solve that. No, I mean, we have not been using SysML as a system modeling tool. We've been using it as an information modeling tool.
Okay, yeah.
But because there are something called ports and things like that in SysML, and just to have a clear definition of the relations or the mappings between different layers, we've been using these ports. So that's been a part of the standard, that on the next level, this is represented by a combination of this, and this. And that's been really powerful. And that's why everyone is now moving to SysML. But version 2, we have not really touched. But we have another task in Arrowhead dealing with SysML v2. But they are doing it from a system modeling point of view, not from an information modeling point of view. So I don't know what will happen if we need to stay on version 1 or. I'm not really involved in STEP any longer. I'm much more involved with IDO and the Norwegian stuff now. But this was just, I've been involved in running this project for more than 25 years. That's why I was tasked to talk about this.
Fantastic. Thank you.
Just a comment on that. The last time we discussed this in ISO TC 184 SC4, I think it's about half a year ago, and then the conclusion was to stay with SysML version 1 for the time being. I guess questions about SysML to version 2 being stable enough, that was, at least some people brought that up.
Yeah.
I haven't worked with it myself, so I cannot judge it. I'm just referring to what was said in a meeting in SC4.
Yeah, thank you.
We are approaching the end of this session. I think what we will we didn't get many questions in the chat. We didn't get any, and if any of you have questions, please send it to us. Send it to me, and I will distribute to the rest of the group who is working with this. Next time is really answering questions and a question and answering session, and also to go into a detailed. I think we will take a look at it after this meeting and see what we should concentrate on, and I will try to get out information of that before the meeting, say mid next week by Wednesday, so you can see what we are planning to dig into in the next meeting. The recording will be uploaded on the PCA YouTube, same place as the 3 first sessions, and it will also, as I said in the beginning, be uploaded on the PVN OwnCloud. Anything else we should mention before we close? If not, thank you so much and have a nice day.
Thank you all for staying all the time. Thank you.
Thank you. Have a good
Thank you for a
weekend.
good presentation. Thank you.
Thank you for a good presentation. Have a nice weekend.